Hello, everyone. Welcome to 120 plus videos. I think 123 or 24 videos so far now, this channel, since the launch of the last month. So that's only 1 month and a half. Already we created 120 plus videos. So if you haven't subscribed this channel, you probably going to miss a lot of new videos. So please subscribe now so that you can watch all 120 plus videos in one hit. Just access to playlist. How do you subscribe? Oh, just click that bell. Doesn't cost anything, just easy. Click your finger and that's it. Thank you for doing that. Now today we're going to show you how to do this questions. We got several interesting questions, especially the last question. We got a question says we have a function. It's a quadratic function. So the parabola x squared minus plus 3x plus 5. So therefore, we're going to find out what is the first question. Consider we have the point P is 1, 0, which is x-intercept. So, well, actually doesn't, it's not x, it's on a x-axis. There is another point, is called Q. So Q is on the graph, which given the x coordinate is I, the y coordinate is FA, obviously. So we need to find the gradient or slope of the line connecting P and Q. So what we do, we're using the M is gradient equal to delta y rise over run. So we know that. Increase of y divided by increase of x. So increase of y from P to Q is FA minus 0. Increase of x is A minus 1. So the answer is FA, substitute A into the function. So divided by A minus 1. So in terms of A, so we've done that. So question BI is pretty simple. B2, question B2. Now we need to find the gradient of tangent of the graph at P. So we know the gradient slope of the tangent need to be into the derivative of function. So we differentiate the function, become 2x plus 3, then plug A into it, so it's 2a plus 3, that's it. That's another simple question. Question 3 is, we said let the tangent of the graph at x equal to a passing P. So if it's a passing P, so what if A should be? So we know what's, so method 1, I'll say tangent to the x at A, we're using the y minus y1 times by m x minus x1. That's the gradient and the point formula. So we know gradient is already given at the A, then y1 is FA, then x1 is A. So we, now, because of the P1, 0 is on the tangent, we substitute x become 1 and y becomes 0. So we can solve that equation. So become a squared minus 2a minus 4, then factorize, so a is 4 and, or 2, negative 2, sorry. So we got two answers. Or you can use the, from question 1 and 2, we can say the gradient of tangent at A is given by, from question A, from question 1, question 2 is 2A plus 3, those equal, and solve the same equation. So we got same answer. So there's two methods to solve that. So these are the two questions we solved for the A. Now the last question is very interesting. I haven't solved. I'm going to show you how to do this. So what is the shortest? So we say we're going to do y, replace x with the x minus k. We don't know what the k value is. So we need to move, obviously, function from, so we call translation of the function to the right, close to the point P. P is already given, we know that, 1, 0. So we now found that the shortest, the distance from P to the graph. So now shortest the distance from P to graph means we need to move the whole graph, that turning the old, sorry, we need to change the old turning point, we call TP, to the new position here, so that this particular distance is the shortest. So therefore, we need to find that new turning point equal to what? So let's do that. So we need to find a new turning point. So we replace fx with x minus k. So it means plug this in. X minus k squared plus 3, x minus k plus 5. So the x replaced with that. So we translate it to right k values. So now, because that's the new function, so we're going to, because turning point is when the difference, turning point means the stationary point. So we need differentiate equal to 0. So I'm just said at the new TP, the f dash k minus k must be equal to 0. So let's do that. So we're going to do differentiate k minus x minus k. So 2x minus k plus 3. That's it, because then you k minus k differentiated with respect to x is 1. So it's 5 is 0. So we want to make it equal to 0. Now, because we move to the position of the new position, the x has to be below, it's directly under point P. So that means x must be equal to 1. So because that's the shortest distance, geometrically. Because if you move to the other place, it won't be shortest. Because if you move to here, that's longer. Move to here, that's longer. So direct underneath of the P. So that means x must be equal to 1. So we substitute into the 1 minus k plus 3 equal to 0. So therefore, 2 minus 2k equal to negative 3. So therefore, negative 2k equal to negative 5. So therefore, k must be positive 5 over 2. So therefore, we need to shift all the TP to the right, to the new TP by, on the right, towards right, by 5 over 2 units. So that's solve the k. It's quite an interesting question. So it means you need to move the older turning points to the new position directly above the P. That's the shortest distance. All right, then you can use the gradient equal to 0 to find the K? This is a great question. So thank you for watching. And if you like it, please give us the thumbs up. I'll see you next time.